Morning everyone, welcome back. And today we're going to have a little short run through of graphic types that we talk about in graphic communication. If you're here looking for a really in-depth description about the difference between raster graphics and vector graphics, then it's probably not the video clip for you. There's lots of good ones on YouTube that you could go and look at. This little one is specifically for pupils who are doing higher graphic communication up in Scotland. What you can see at the top are two little images, VS and VS, and you'll notice that they look different. One is a little bit pixelated and unclear, and the other one is sharp and crystal clear. What we are going to have a little discussion about, or a little investigation about, is raster and vector graphics, and which one is best. Now the answer to that is there is no one of them better than the other. It really depends on what it is you're going to do with it. So let's have a look at, first of all, rasters. And you'll be familiar with these because you use them all the time if you take pictures with your phones. They're made up of tiny little dots or pixels, and they are the single or the smallest little part you'll see on a display device. Sometimes you've looked, if you're going to buy a tablet or a phone, you might look at the screen resolution, and the more pixels it has, it means the sharper the image is going to be. However, it's still going to be limited by the amount of those pixels that there are, which is why you get this thing called pixelation. On the other hand, vector images are not made up of pixels. Those are mathematical calculations. And if you do maths, you maybe come across vectors. It's how we describe how to get from one point to another point. And it's a mathematical calculation that gets done. This little illustration hopefully gives you an idea. On the left we've got painting with pixels, and when you look through a magnifying glass at it, you can see that we've got these tiny little squares that show up. Now what's going to make this a wee bit difficult is that the screen recording software that I'm using on here automatically makes things look pixelated anyway because it's quite low quality. So you'll just have to take my word for it when I tell you that the one on the right hand side is crystal clear. One on the left you can see the pixelation when it's magnified, and the one on the right, it should look crystal clear on your screen. But as I said, this screen grab software that I'm using probably still makes it look a little bit pixelated. As I said in the previous slide, if you take a photograph with your camera, or if you scan anything, if you've got a magazine or an old family photograph that you want to get onto the computer, you might use a scanner for it. And if you do that, you're automatically creating a raster or a bitmap image. And here we've got kind of example of what happens when you enlarge it. So on the left hand side we've got a picture of that flower, and then we enlarge it up, and if we go too high with it we end up with something which is almost unrecognizable. But you can see quite clearly all the little pixels. Some are dark, some are light, and that's what gives you that tonal scale in photographs. It makes them look photorealistic, which is a phrase that we should try and remember, photorealistic. If we look at vectors on the other hand, they are infinitely scalable. And that's because it's all to do with the mathematics behind it. It's got nothing to do with pixels. So when we scale something, this little example of a star within some circles, when you zoom it in, it retains its sharpness and its clarity. Once again, I apologise because this screen grabbing software probably makes it look quite pixelated, but in actual fact it's not. And I'll try and show you some examples of these as we go through. They've got common file formats, and these ones you'll have seen before: BMPs, JPEGs, GIFs, TIFFs and PNGs. You've all been familiar with those, maybe not so much the TIFF one, but you've certainly used BMPs, JPEGs, GIFs and PNGs. There's lots of detail I could go into about those. There are three of them: the JPEG, the GIF and the PNG do a thing called lossy compression, and that means that the file size gets compressed without losing clarity on it. A BMP is an actual size one, which doesn't get compressed. But don't worry too much about that, not that important, for us anyway. If we look at vectors, the common file formats for that are AI for Adobe Illustrator, PDF, which you've heard about, SVG you may have seen, DWG you will definitely have seen because when we use Inventor and we create our production drawings, they have a DWG extension. So you have created vector graphics in the past, but most of the stuff that we've dealt with in the desktop publishing side has always been raster. The advantages of rasters, because it's made up of these pixels, which are tiny squares of colour, it's really good at doing all the different tones and scales that you get in photographs. It's photorealistic. Here on the left hand side we've got a lovely landscape picture of a forest overlooking a lake, but once again when we look at the enlarged or the zoomed in section we can see that it becomes pixelated, a little bit like my voice just did. So the advantage is that you can get photorealistic images using raster. Disadvantages, there are quite a few. First one is that it can't be scaled up. And the reason for that, once again, I'll keep going back to that, is the number of pixels that it has. It has a limited amount of pixels, and when you zoom it up, it doesn't create any more pixels. It simply makes the ones which are there look bigger and then jaggy. If you want to say, well, why don't we just convert it into a vector image, it can be done, but it's very time consuming, and sometimes the outcome still isn't as clear as a true vector image. So the answer to the question that you may be asking is, well, why don't we just make everything vector? One is it's not very good for photographs, and two is that converting rasters to vectors isn't always successful. Just to remind you again what it looks like when you zoom up a raster image, it loses its clarity and its definition. And the larger the photograph, the larger the number of pixels, which means a larger file size. And if you've got an old laptop like I've got and you try and do something with a photograph which is a large file size, it can take ages to do the processing on it, whereas a vector image stays the same size. And if you're a commercial graphic artist and you want someone to then do something with your work afterwards, you want it to get engraved or to get cutouts made from it, then the people who do this using computer aided design and manufacture, they need vectors, they need that mathematical data. Pixels aren't much good to them. So that's the disadvantages. Oh, and finally, when we come to printing, and we'll cover that a bit later in the course, there is a bit of a problem when you try and print using what are called spot colours. But once again, don't worry too much about that because it's only a tiny little bit that we need to talk about, and we'll do that as we go through the course. So for now, the biggest disadvantages for raster images are that you can't scale it up, and the bigger the number of pixels that you have in it, the bigger the file size and the more difficult it is to process. That's the main disadvantages. Let's go to vector graphics now. What are their advantages? Well, they can be scaled up because it's mathematical, and therefore it doesn't matter how big you make it, the equation for making that stays the same size, and therefore it has a small file size. It's only a file size that's got some data in it, nothing more. They're great for logos. If you think about logos that you've seen, they tend to be solid colours. We don't have many changes in tonal scale when you think about logos. Kentucky Fried Chicken or McDonald's, those colours tend to be quite flat and uniform. So they're ideal for those because you can have it on the bit of paper that covers your straw in McDonald's, and it can be zoomed up to the size of a billboard. And it doesn't lose any of its definition or any of its clarity when you do that. And you can see the little orange stars, as they get bigger, they maintain their definition and sharpness as we go through. Disadvantages, as I've said before, and hopefully by saying it you'll remember it, they're not very good for photographs because they can't do the different tonal scales and gradients that you get in photographs. But they're very good for solid colours like we see here. So the vector one on the left hand side, when we zoom it up, it keeps its clarity. The raster one on the right, it gets a little bit jaggy and pixelated. Now this one might be quite difficult to see on your screens, but on the left hand side we have a vector photograph image, and you can see it looks a bit like someone's drawn it with a crayon, whereas the raster one on the right hand side, it's as you would normally expect to see photographs. It's nice and clear, and it's got lots of different scales and tones when you look at it, so it looks photorealistic. So just to go through the advantages for raster, it's got low file size generally, it's easy to use, and it can be edited using common programs. You've probably done it with your phone. You can actually edit raster images on your phone quite easily using the software that's free and easily available. The advantages for Vector: it can be used to create laser cutting toolpaths and 3D printing. You can resize it without any sharpness, and it's clear and precise no matter how big or how small it becomes. Disadvantages for raster: it can become pixelated, and it's less suitable for high quality and large printed items, which is said before because of this pixelation idea. Disadvantages of Vector: it can't be used for photographs. You need specialist software to do it, and it can be expensive to do that software. Now I'm going to try and show you a couple of examples here, so bear with me. And I'm going to look at, first of all, an Autodesk Inventor drawing. Now this drawing is a vector. So when I zoom in on it, I'm going to go over here to my zoom. And as I zoom in, you'll see the lines initially are jagged, but then they smooth out as it gets recalculated. So I can zoom in infinitely here, and it more or less maintains its clarity all the way through. That's because it's a vector image and it recalculates as it goes. Now if you look around here, you'll see it's a little bit jagged, but that's more to do with the screen resolution on my laptop than it is to do with the image itself. But if you look at that, you'll see that's quite jagged just there, so you would expect when I zoom in that it would get really jagged, but you can almost see it recalculating as it goes to maintain that smoothness. On the other hand, if I look at a raster image of that screen, so I did a screen print, and then if I zoom in on this screen print, you'll see the difference. It doesn't recalculate, it simply pixelates. Now what I'm going to do now is go to a PDF. Now PDF's a kind of unique one. A PDF is classed as being a vector graphic, but the images which are in it can still pixelate. That's because they originally started out as raster images. I know that's a bit of a puzzle to get your head round, but if you stick with me, then I promise it's true. So if I zoom in on this, what you will see is that as my laptop gradually recalculates things, you'll see it becomes clear. So I'm going to zoom in again. It'll take a few seconds for the laptop to reprocess things, but just have a look at how clear these are. And when I zoom in again, they maintain their clarity all the way. Eventually you will see some pixelation around here. That's because they were originally raster images. If I zoom back out, so I can zoom out, it stays nice and sharp. And when I zoom back in again, once my laptop catches up, you'll see that it maintains its sharpness all the way through. And a final little picture here just to illustrate it. We can see down on this one here, we've got the little picture of the dog. It's lovely and photorealistic, so it looks like a little corgi dog, but when you zoom in on his nose, you can see he gets all pixelated. However, this one here on the right hand side, which looks a little bit more like a drawing and a little bit less like a photograph, that's because it's done with vector graphics, which can't do photorealistic. And when you look at the enlargement over here, that becomes even more obvious. There's very clear patches of dark and then very clear patches of light, but there's no soft transition in between. So what's your task going to be for this, so that we can make sure that you've learned it? I'm going to set a little assignment for you in the next day or so, and you're simply going to look at these file extensions. You're first of all going to tell us what they stand for, then decide whether it's a vector or a raster file type, and finally you're going to try and find a situation where that file type would be appropriate. Once again, if you've watched all the way through this video hoping for an in-depth, comprehensive description of the difference between raster and vector graphics, then it's about 9.5 minutes of your life that you won't ever get back. However, if you're doing the higher graphic course, then it should have given you enough to answer any questions which might be asked of you. Thank you for watching.